guys, here's your quick 5-minute review of today's lesson. Lesson 11.6, Radical Expressions, and the goal today was to simplify radical expressions. So let's take a quick look. Today in class we went over the vocabulary and the rules for product property of square roots as well as the quotient property of square roots. The first thing we talked about in class today was that the radical expression is an expression that contains the radical sign. So the example that we have here is the square root of 14x, and the 14x that's underneath the square root symbol is called the radicand. Any expression that's underneath that radical sign is called the radicand. The key important concept is to make sure when simplifying that the radicand has no perfect square factors other than 1 when we finish up. The second part is that the radicand has no fractions. And then the third is that there are no square roots in the denominator. And these are 3 steps for making sure that we are simplified in the simplest form. So when solving this, we can look at these 2 properties as being our key or our guide for doing the work in class. We talked about the square root of a number or the square root of a variable being the combination or the product of 2 numbers. And when we're looking at this, we're looking at the factors and trying to make them into the factors that have a perfect square. So that makes things easier for us to find the square root of it. So for example, the square root of 50 can be broken down into the factors of 25 and 2. And we want to use 25 and 2 versus 5 or 10 or some other type of factor of 50 because 25 is a perfect square. So when we do this, we get the square root of 25 times the square root of 2. And that's still going to give us the product of 50, which is what we ultimately want. When we solve this and when we simplify it, we can see that the square root of 25 becomes 5. The square root of 2 stays the same. So that we can come back here and check our 3 steps. The radicand has no perfect square factors other than 1. Well, the number 2 proves that. The radicand has no fractions. Well, we just have the number 2. There's no fractions. And there are no square roots in the denominator. Of course, there's no denominator in this one, so we're safe. The same thing holds true when we're dealing with exponents, x squared and y. We can see that the square root of x squared is going to give us x. And the square root of y is going to stay the square root of y because we can't factor that and find the square root of it. The second part of today was dealing with the quotient property of square roots. And we're going to treat this very much the same way that we did with the product property. We are going to look at it in terms of the radical expression a over b and find the square root of that. And the first thing we want to do is to break it down into the square root of the numerator, which is a, and the square root of the denominator, which is b. When doing that here in the example, we have 3 over 49. So you can see how we've done square root of 3 over the square root of 49. And what this allows us to do is to break things down based on the square roots. We can see that the square root of 49 is going to give us 7. The square root of 3, we can't get rid of the square root of 3. It's not going to give us anything that's going to give us a perfect square as a factor because it's just 1 and 3. So the square root of 3 over the number 7 is in simplest form. And again, you see how we do this with the variables. Square root of x to the 6th over the square root of 16. The square root of 16 becomes 4. The square root of x to the 6th, remembering our rules for exponents, becomes x to the 3rd. This is important because we have to remember that the square root of x to the 6th becomes x to the 3rd because x to the 3rd times x to the 3rd, when we multiply the same base, our exponents become 3 plus 3, which would give us x to the 6th. So a quick review on our rules for exponents. That sums up our first part of today's lesson, and I will take a look at the second part here in a minute.